Okay, so we are talking about the properties of closure properties of regular set or regular language. So, we have seen the regular set is closure under union, intersection, concatenation also. If you have two regular set L 1 and L 2, regular sets or regular language. In the last class we have seen L 1 intersection L 2 and L 1 union L 2 are both regular. Okay. In fact, last class we have constructed a DFA which is accepting this L 1 intersection L 2 and L 1 union L 2. Even L 1 concatenation L 2 is also regular. Why? Because it is coming from a regular expression, because since this is regular. So, we have a DFA for this, we have another DFA for this. So, once we have a DFA, we have a R 1 regular expression, we have a R 2, then R 1 R 2 is also a regular expression which will corresponding to L of R 1 L of R 2, and so R 1 R 2 will corresponding to this this language. So, R L concatenated with L 2 is also regular. So, even the close star is also regular, which is immediately coming from the regular expression. Now, today we will discuss some more properties, some more closure properties like complement. We have given a regular set, is the complement is also regular. So, a regular set is closed under complement. So, that means what? Let we have given a this sigma set of input alphabet, finite set of input alphabet, and suppose you have given a language which is a subset of any string consists of the alphabet coming from sigma. Now, suppose this is regular, we have given a regular set or regular language L. Now, the question is whether the complement means L C or L prime, whichever notation we will use. This is nothing but the set of all strings which are not in L. The question is this regular? Is complement is regular? Okay. And the answer is yes. We have to show that. We have to show the complement is also regular. So, how to show this? In fact, if we have given a regular expression for a language, can we have a regular expression for the complement? So, first of all, how to get the complement? I mean, let L be L is regular. This means there exists a DFA which is accepting L. So, that means all the string. So, L is the, so this is the all the string, if x belongs to L, then delta hat of q 0 x is reaching to a final state. Okay. So, that is the L. We start with q. So, with the x we should reach to a f, one of the f. There may be many final states. So, this is given. Now, from here how we can construct a DFA which will accept the L dash or LC, L complement. So, for that what we do? We just take this, we construct a M prime which is same as the states are same and input alphabet we can keep it same without any loss of generality, delta is also same, q 0 is same, only thing f we do the f complement. So, f is this is f prime, f prime is nothing but q minus f. Okay. So, we will make all the other states as a final state other than this q minus f, that is the only change over here, otherwise everything is same. In that case, we claim that if language accepted by M is basically L prime or LC. Why? Because so what are the language accepted by this? This is set of all string such that delta hat of q 0 x must belongs to this must belongs to f prime. So, if a symbol is must belongs to f prime, then it should not belongs to should not belongs to f, does not belongs to f. That is all. So, this is the so this is basically L prime, set of all string which are not accepting by L. So, that will be accepted by L prime. So, this is nothing but okay. So, we just given a DFA, we just make all the other states other than the existing final state, we just make the those states as a final states. So, that is the that will accept this M, and this should be DFA. It is not for NFA, this is not possible, because we can take an example for epsilon NFA. Given epsilon NFA, if we do this, then it is not possible. So, we can just take a quick example. If we have a language W, suppose it is A B, the W does not, the string W does not contain containing a substring A B. Okay. Now, what is the complement? Complement is okay. Before the complement, let us draw the. So, what is the complement? Complement is W belongs to this. W does contain. W contains A B. Now, first of all, we have to show this is regular. So, for that we need to get a DFA. So, we can easily have a DFA. This is the starting state, say q 0, q 1 and say q 2. So, with A, if we have B, now with A we are here, with B we go there, and with A B. So, it does not this is the final state. Okay, it does not contain the string A B, because if we have A B, then with A we go here, does not contain a substring A B. So, okay. So, this is the thing, and what is the complement of this? So, this is the DFA. No, this is the DFA containing this. So, I make this as a this is our M. So, we have a DFA, we have a regular language which is containing A B, because if we take if we just take A B, so with A we go here, with B we go there. So, A B B also accepting, A B B, B A B B, all the string is accepting. Okay. Now, complement is this one. So, now from here we need to have a DFA which is accepting this language, that means the language which is having no substring containing A B. So, this our method is we just make the take all the states other than this final state as a final state. So, what is M prime? So, rules are same, only thing Q1, Q2. So, this is B, this is A, transition rules are same, this is A, this is B, this is A B, only thing we make these two as a final state, we make these two as a final state. Okay. Then this is accepting the string, set of all string which are not containing the substring A B. Okay. Now, this method will fail when we have epsilon NFA. This is okay with the DFA, but if we have epsilon NFA, we cannot just make the complement of the final states, that will not work. For example, if we have this epsilon NFA, say M1, we having Q0, this is the starting state, we have 0, Q1 with epsilon, we have 1, Q2, this is the final states 2. So, this is the epsilon NFA. So, which is the language accepting this? This is 0 star, 1 star, 2 star. So, any number of 0 followed by any number of 1 followed by any number of 2. Now, this is also accepting epsilon 0 1. Now, if you apply the same rule on complement, so M1 star is nothing but, so we are keeping the transition as same Q2. So, we are keeping the transition same epsilon 1 epsilon 2, only thing this is the starting, only thing we are changing the final state as the complement of the here it was this two was not final, we are making final, we are keeping this not final. Okay. Now, if you do that, this is also accepting epsilon, this is also accepting 0 1, but this is accepting by this. So, this is not correct. So, this way of doing is not correct, while this automata is epsilon NFA. It is perfect if the automata is DFA, then we can do the this complement things. Okay. So, now we will talk about how to get the complement for the regular expression. So, suppose we have given a regular expression for of L of a language. Now, how to get the regular expression for L complement. So, how to do that? Since we have a regular expression, from here we can have a epsilon NFA, we can construct. So, from here we can have a NFA or directly DFA substrate construction, and then from DFA we can have a complement DFA. Complement DFA means we just do the changes of the final states. Final state we make the other state as a final state, that is we can refer as complement. Then that will give us the regular expression for, then we can have a regular expression for the new DFA, regular expression of L, that is all. So, given the regular expression of L, we can follow this step to get the regular. This is this complement DFA means we just change the final state by taking the final state other than the final state of the original DFA. Okay. Now, we will discuss another property which is called reversal of a string. Reversal. So, sigma is the set of alphabets. So, suppose W belongs to sigma star. Now, if W is say A1, A2, AN, where AI are coming from sigma, then reversal of W is denoted by, we just reverse this. So, AN will come first, AN minus 1, A to A1. We will just reverse it, that is called reversal of the string. So, for example, if we have 0, if sigma is 0 1, if we have 0 0 1 0, R means we just reverse this. So, 0 will come first, then 1, then 0 0. This is the symbol we are using. This is the reversal of a string. Now, reversal of a language means the reversal of each string in that language. So, suppose we have given a language W, L. Now, LR will just denoted by WR. That is all. So, WR, set of all WR where W belongs to L, this collection. Okay. So, we just take the string and we reverse it, that collection is LR. So, for example, if our L is say 0 1 0 1 1 1 1 0. Okay. Now, what is the LR? Reverse of each of these, reverse of this, reverse of this, reverse of this. Now, how to get the reverse? We will just take 0 1 1 0. So, it is 1 1 0, this is 0 1 1. This is the meaning of LR. Now, the question is, if L is regular, then whether LR is regular or not. That means, whether the regular set is closed under the reversal. The answer is yes. So, we have to prove that, or we have to. So, if L is regular set, this implies LR is also regular. Okay. So, how to show this? So, we can show this by either by regular expression, but we have to formally show this, but informally we can just justify this like this. Suppose suppose L is regular. So, L is regular means what? Suppose L is regular, either regular expression or regular set. So, this implies we have a epsilon in F A or DFA, DFA can also treat as epsilon in F A. So, we can construct a epsilon in F A M or M star. We can construct a epsilon in F A M which is accepting this L. Now, from here we can construct a epsilon in F A, new epsilon in F A M star by just reversing the arc. So, if there is a in M, if there is a path like this P to Q, so this in M star we will just make these arcs reverse, like we will make it this way. So, we will reverse the arc. So, if this is A could be epsilon also. So, in M it will be like this, it will be Q to P. So, we will just making the reverse of arc. Okay. And then, so for this one, so if this is say M is say Q, this is epsilon in F A, Q sigma with epsilon, sorry, Q sigma with epsilon, then delta Q0 F. Okay. And we are assuming it has accepting only one okay. So, this is the, and then what is the M prime? M prime is we are putting Q same, sigma is also okay, delta is changing by reversing the arc, and starting state we will need to have a new starting state P0. And what is the final state? Final state will contain the Q0. the starting state of this, that is all. And then P 0. So, what we need to have? So, if there are, say in this case, if there are many final state f 1, f 2 like this f k, then from P 0 we have a epsilon move over here, and we are reversing the arc. So, that way the only the reverse language will be accepted by this m prime. Okay. But this is the construction, and then from this m prime we can have a regular we can convert into DFA, and from DFA this is the regular expression we can have. But we can formally prove this by with the help of induction and with the help of regular expression. Okay, so, this is using the this is the formal proof using the regular expression. Okay, the theorem is, if L is a regular language, then this implies we have a R, or we have a R such that L of R is equal to L. This R is a regular expression, because if it is a regular language, then we have a DFA, and from the DFA we can construct a regular expression. Okay. Then we want to show that this LR is also regular, the reversal. So, we can show that LR is nothing but L of, this I must put S, because R we have used over here as a, sorry, this we can put S. Yeah, so this R, LR is nothing but S to the power R. Okay, so this we have to show. So, that means we can show that, if we can show that S to the power R, if we can show for a regular expression S to the power R is equal to, then we are done. This we will prove by help of induction, and for that we need to have this result on the operator using the reversal. What are the result? If S 1 and S 2 be two regular expression, then if S is S 1 plus S 2, this implies S to the power R is nothing but S 1 to the power R plus S 2 to the power R. This is trivial, because we can just take some example. This is the union, this will be union, and this is the reverse set. So, this is trivial, and this is true for concatenation also. This is S 2 to the S 2 R, S 1 R. This also you can just verify. This is also trivial. And if S is S 1 star, then S to the power R is basically S 1 to the power R star. This is small r. Okay. So, these are the result we will use for proving this. Okay. So, again we have to prove this by induction, we have to show this result is true for the base case. This is we will prove this on the number of operator. So, suppose we assume that if the number of operator is 0, the base case. So, base case means we have only 3 possibilities. S is 5 epsilon A, where A is this is the base case, here the number of operator is 0. Then in this case, this is the base case with the 0 operator. Then in this case, what is so what is SR? SR is this to the power R, this to the 3 cases, A to the power R. So, these are basically what? These are basically same as phi, this is basically same as epsilon, this is a singleton set. So, that means L of s to the power r is same as L r to the power L s to the power r, because these all are singleton sets. If we reverse it, it will get the same set. So, this result is true for base case, the number of operator is 0. Now, if we assume that the result is true for up to more operator like up to k, suppose this is the induction assumption, suppose this result is true for up to k number of operator, is k or less than equal to k. Now, we take a regular expression, let r be a regular expression with k plus 1 operators use. Okay. So, we assume the result is true for this. So, if we have a operator like R 1 which is having in the R 1 if there are k number of operator, then we can write that L of this is R 1 not, this is S 1 S. So, S 1 to the power r is S 1 to the power r, this is the assumption. Okay. Now, if it is a k plus 1 operator, then S can be written as either one of this form S 1 plus S 2 or S 1 S 2 concatenation or S 1 star, and in that case all of this S 1 S 2 having less number of operator, because we have used one operator already. So, they will be having the operator less than equal to k. So, by the assumption of induction hypothesis, we can say this result is true for both of these. Okay. So, this is case 1 is this. Then what is this? This we know. Okay. So, now we take the r. So, this is S 1 r plus S 2 r. This we know. Now, this is basically L of this is nothing but L of S 1 r union of L of S 2 r. Now, by induction hypothesis we assume the result is true for up to k, and there are at most k many operators there. So, this can be written as S 1 to the power r union S 2 to the power r. So, that is all. Then this will be written as r of S to the power r. So, the result is true for k plus 1 operator, and similarly we can prove it for case 2. Case 2 will be just concatenation the S is S 1 S 2. In that case, so this r is basically S 2 r S 1 r. Now, if you take this language, this is basically L of S 2 r concatenate with L of S 1 r. Now, we assume this induction is true for this. So, this is basically L of S 2 r to the power r, then L of S 1 to the power r. So, this is nothing but L of S to the power r. Okay, this is the case 2, and case 3 is the star. So, if this if S is S 1 star. So, we have used one operator. So, this S 1 must be having less than at most k operator, because this is k plus 1 operator. So, if you take this is nothing but S 1 r to the power star, this we can easily prove. Now, L of this is nothing but L of S 1 r to the power star. Now, we by induction hypothesis, this is nothing but L of S to the power r to the power star. So, this is nothing but L of s to the power r. So, the result is true for this number of operator is k plus 1. So, by the induction method we can say the result is true for all r. So, this is the formal proof of this closureness under the reversal. So, if we have given a language, then if we revert all of the string of the language, then the new language is also be a regular language. Thank you.